All right, in this video, we're going to talk about taking concentrated solutions and diluting those. And so maybe some of you guys have seen bottles around your house that say that they are diluted, or maybe you come across something that says that it is concentrated. Chemists often order things that are very concentrated, so they have a high molarity. And we use those stock solutions to then make diluted solutions for lab, for example. And so they are weaker. There's more solvent that is in the solution than there is solute, the thing that is being dissolved. And so how do chemists go about doing that? That's what we're going to get to today in this video.
Okay, so here we have our 12 molar stock solution of, it's Kool-Aid, but we could use, this could be anything from our lab, hydrochloric acid, sodium hydroxide. And so Mr. Thorne and I would go in the back and we would grab these jugs, and if we wanted to dilute them, so let's say I wanted to make a 300 milliliter total volume of a 6 molar concentration. So this is going to be diluted. It's going to be half concentrated, if you can kind of track with me on this. So how would I figure out how much of the 12 molar concentrated stock solution would I use to make the 6 molar hydrochloric acid? Okay, so when we want to make our diluted solutions from our stock, we always take the molarity. So this is the equation we're going to use. So we're going to take the molarity of our stock concentration times the volume of the stock concentration is going to be equal to or proportional to the molarity of this diluted solution we want and the volume of the diluted solution we want. So this is a ratio, and in math, of anything that you will ever use in your life, this is more common than anything. So for our practice problem, we had 12 molar hydrochloric acid, and we want to know what volume of that stock solution we're going to need to use to make our diluted solution. So our diluted solution, we wanted the strength to be 6 molar, and we wanted 350 milliliters of that being made. Okay, and so this is multiplication here. So when we do this, we're just going to multiply that, and that's 2100. That's molar per milliliter. Okay, now to solve for V1, we need to take and divide it by 12 molar. Those cancel. So that when we do this to one side, we got to do it to the other. And I'm writing the units so that we know what we're solving for when we're done. So I know my answer when it is done is going to be it's going to be in milliliters. So 1200 divided by 12, and we get 175 milliliters. And what did we solve for? Well, this is my stock solution. So we just solved for, to mix this, we're going to have 175 milliliters of our stock solution. Okay. But I want a total of 350 milliliters when I'm done. So how do I figure out how much water I would need to make a total of 350? So you're going to take 350 milliliters and you're going to subtract whatever that stock is. And this one is going to be 50-50, 175 milliliters of our stock solution and 175 milliliters of our water. So I'm going to mix that up real quick so you guys can see that. Okay, so I've put 175 milliliters of water in, and I'm measured out 175 of my stock solution. And so that is our diluted solution. It's still pretty dark. You can kind of tell that. Okay, so that's pretty straightforward and easy. Now that's pretty easy if we're doing 50% concentration. I can kind of easily say that and just kind of do the math. 50% of these things, right? It should be pretty easy. But what if I wanted to make something that was pretty diluted down? So let's say I wanted to make a solution, 350 milliliters of 0.5 molar hydrochloric acid in this example. So what would I do? So it's going to be the same process. Okay, our stock solution is 12 molar again. We are solving for how much of that we're going to use. This time we want 0.5 molar solution, and we still want 350 milliliters of it total made. Okay, so I'm going to multiply these together. So 350 times 0.5 is 175. Half of it, right? Should make sense. Okay, so I'm going to divide by 12 molar again. So V1 is going to be equal to 175 divided by 12. So my answer is going to be in milliliters. So I'm going to have 14 point, I'd make that 6 milliliters of our stock solution. Okay. And so if I want 350 milliliters total, how much water am I going to have? Okay. So I need to take 350 and subtract 14.6. And we're going to have 335.4 milliliters of total water, okay, that I'm going to need to mix. So I'll mix that up real quick. Okay, so here we go. This one all mixed up. So if you take a look, if we were using hydrochloric acid, we would only measure out 14.6 milliliters of the hydrochloric acid. Way more water. This is way more diluted. Okay, not very strong. Okay, and if we compare these to our other ones, okay, you can see that, here's our stock 12 molar. It's really strong. Okay, this is going to be half diluted, 50% strength, 6 molar, and then this is going to be our super diluted, okay, 0.5 molar. And you can see the color differences and the variation there. So just remember, there's our base equation that we're going to use. Put what you know where it goes in the equation. Okay, last step is to figure out the water. So whatever the total solution is that you want, okay, you're going to subtract your stock solution, your most concentrated solution, and subtract them to make sure that these are going to add up to our total here. So how much water you're going to need. So pretty straightforward. There you guys go.